Hi friends, in this tutorial we will discuss about the analog read. In the next tutorial we will discuss about the interrupt and the timer of the LiLan board. I will make a series of videos on the drone development by making use of this LiLan board. To read out the analog signal, we will use this function inside the Arduino. So we have to give analog read and the GPIO pin number. If we are talking about the ADC, analog to digital converter, we are assuming this is the linear, but it is not linear. This is the one of the limitations of this ESP32. I am giving this link. In this board, we are using the ESP32 along with the IMU. That's making a more powerful this IoT board. You can use to develop the drone as well as the ground system. This is the graph that's showing voltage versus ADC reading. If you look at these 2 points, there is no difference between the 0 and the 0.1. Similarly, there is no difference between the 3.2 and the 3.3 volt. Other supportive functions we will discuss in another tutorials about these functions, just like the analog read resolution, analog set width, and analog set cycles, analog set samples, analog set clock divider, analog set attenuation, analog set pin attenuation, ADC attach pin, and so on. So I will make a tutorial on this if time will permit. Right now I'm talking about the basic function, that is the analog read. Let's take an example. In this example, what I'm doing, I'm using a potentiometer, and after that, one end of the potentiometer is grounded, the second end is connected to the 3.3 volt, and the middle one is connected to the pin number 34. Next one, the pin number 4 is connected to the LED. As we vary the value of the potentiometer, according to that, the brightness of the LED will change. After that, we have to power up the board through the 5 volt and ground to the ground, RX to the TX, TX to the RX. And finally, you have to connect with the computer. Now, understand the coding. As I told, we are using the potentiometer. We are connecting the pin number 34 from the potentiometer. And we are taking another variable, port value. Whatever the value we read out on this pin number 34, we will store in this variable port value. If you are willing to print the value, whatever you are receiving, then you have to enable the serial communication. So for that, we are using the serial.begin, delay choice is yours. Next one, in the loop section, we will read by making use of this function, and port pin we have to give 34. Directly you can write here 34, printing the value. This is one of the example. In second case, we are using the same pin 34 that is connected to the potentiometer. We are taking one variable in which we will store the value, whatever we reading analog value. To understand the analog write, you can go to the tutorial number 2. First, we are using the LEDC setup function. In this, we are giving the channel number and frequency and the 10-bit resolution. The second function we are using LEDC attach pin. Channel number 0 is attached with the pin number 4. Now, also we have to set the resolution. That is the 10-bit we are setting the resolution. Read resolution. Okay. Because the reading and the writing resolution should be same. That's why we are using the 10 here. So it is choice is yours. You can use it or not use. Not required. Next, in the loop section, the first statement is port value. In this, we are reading the value, whatever the coming on the pin number 34. We are storing in one variable port value. Next one is we are executing LCD write function. So in this function, we are giving the channel number that is associated with the pin number 4. So we are giving here channel number and we are writing here port value. Whatever we are receiving, that we are writing. As we change the value of the potentiometer, according to that, value of this variable will change. If value of this variable will change, we will write here, brightness of the LED will change. Next tutorial, as I told, on the interrupt and the timer of the LiLan board. Please like, please subscribe. That will motivate us to make more tutorials by making use of the LiLan board. Thank you.